Okay, so here we're going to do double angles with solving. Okay, so we're going to choose the formula that's going to help us the most in solving these equations, just like we were solving trig equations last unit. So 2 cosine 2 theta minus 1. Okay, we could do the rotations around the circle, but for most of us that was kind of challenging. So here we're just going to switch that out with one of the formulas. It doesn't matter if you choose the one with just the sine or just the cosine, but I would not choose the one that was cosine squared minus sine squared, because then we're going to get two equations in there, and we don't want that, right? We want everything to be the same. So I'm going to change it to the cosine. So I'm going to do 2 times 2 cosine squared theta minus 1 equals 0. Okay, I'm going to distribute my 2, so I'm going to get 4 cosine squared theta minus 2 minus 1 equals 0. And then I'm going to kick out my negative 2 and my negative 1 to the other side. So I'm going to have 4 cosine squared theta equals 3. I'm going to divide by 4, so cosine squared theta equals 3/4. And then we've got to take the square root of both sides, so we get cosine of theta equals plus or minus the square root of 3/2. And cosine has the value of the square root of 3/2 for the entire pi over 6 family. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 would be our answer there. Okay, so here I'm seeing I have a cosine, or 2 cosine theta plus sine 2 theta equals 0. So this is the piece that I'm going to change because it's got the 2 theta. So 2 cosine theta plus 2 sine theta cosine theta equals 0. Now anytime I have something with addition and I'm seeing that they have something in common, we're going to take out that GCF. This is the piece that we like to forget. Even though those 2 and the cosine are right next to each other, it's multiplication, so it's commutative. So they both have them in there, so I can pull out those two things. I can pull out a 2 cosine theta. And when I pull that out, I'm going to divide 2 cosine theta by 2 cosine theta, which gives us a value of 1. Plus 2 sine theta cosine theta, when we take out a 2 cosine theta, that gives us a 1 there, but we're still left with the sine. And now that we have 2 factors, we set both of those factors equal to 0. And then we solve them both. 0 divided by anything is still 0, so this is really just cosine of theta equals 0. So cosine is 0 for the pi over 2 and 3 pi over 2. Okay, and this is saying sine of theta equals -1. And sine of theta equals -1 at 3 pi over 2. So there we got an answer that ended up being repeated, and that's okay. It happens sometimes. For the next one here, okay, I'm seeing a 3 cosine 2 theta, so that's the one I want to change, plus a cosine theta equals 2. So I'm seeing that I already have a cosine in this, so I probably want to change 2 cosine to something with a cosine in it. So I'm going to change it to 2 cosine squared theta minus 1 plus cosine theta. And I'm seeing that I'm going to be multiplying a 3 by a -1. So that 2 is going to have to come over here because I'm going to have to factor. So I need it equal to 0 on the right. So when I distribute this, I get 6 cosine squared theta minus 3 plus cosine theta minus 2 equals 0. So I'm going to combine my numbers there. So I get 6 cosine squared theta plus cosine theta minus 5 equals 0. Now again, anytime you have any other number other than 0 on the right side, you cannot factor. So you need to move the 5 to the other side in order to factor. And we can't take out a GCF here because we have that number 5, and we can't take a cosine out of the number 5 because it doesn't have a cosine. So that is what tells me that I do indeed have to use some sort of factoring method, whether or not that's X or X box or guess and check or slip and slide. You have to factor in whatever manner works best for you. So again, I'm not going through factoring in this video. If you need help on factoring, please sign up for Bear Block, stay after school, get that help that you need for factoring. So from the first one, we're going to get 6 cosine of theta minus 5 equals 0. And the second piece is going to be cosine of theta plus 1 equals 0. So here we're going to get cosine of theta equals 5, 6, which is a true value. And you could go into using right triangle trig to solve, but I want you to just stop there. And I'm cool with that answer. And then over here we got cosine of theta equals -1, and that's going to be at pi. Okay, for the next one here we got cosine theta plus 2 cosine theta plus a sine squared theta. So here I'm seeing that I have a sine squared and a cosine in the equation. So this is where using that cosine squared minus sine squared might actually come in handy. So I'm going to use that one. So I have cosine theta plus cosine squared theta minus sine squared theta plus sine squared theta equals 0. And in this case, the signs will cancel, which is why I chose to use that one. You could have also chose not to use that one and substituted sine squared with 1 minus cosine squared from our identities from last unit. But when I do that, those cancel, and I'm left with cosine squared theta plus cosine theta equals 0. So I'm going to factor out a cosine as my GCF, and I'm left with the cosine theta plus 1 equals 0, and then I'm going to set both of these factors equal to 0. Okay, so cosine of theta equals 0 at pi over 2 and 3 pi over 2. And then cosine theta equals -1 at pi. So those would be our values there. If you have any more questions on this, please feel free to see me in class.